Hello guys, for my presentation, I want to first talk about the history of how the first battery was invented, and I'm going to talk about the different types of batteries, how batteries work, and the future of different battery technologies. So our story begins in the 1700s, where PETA was not a thing, and everyone was doing experiments with frogs. This was mainly because frogs are small, easily handled, and there's always a steady supply of them out in the nature. Now, our protagonist, Luigi Galvani, a physicist from Italia, was no exception from this, and legend says that one day he was doing experiments with some frog legs, and he accidentally touched one of the legs with a metal tool. And when he did that, all of a sudden, one of the frog legs jerked up, and this made Galvani believe that there was some sort of electricity stored inside all living things. When Galvani published his findings in a paper, another physicist, Alexander Volta, saw this and believed it was pretty much incorrect. Galvani believed that it was the electricity stored inside the frog that caused the leg to jerk. However, Volta believed that it was the metal itself that made the leg jerk. To prove to Galvani that electricity actually comes from the metal, Volta created this stack. Consists of zinc, copper, and a fabric that's soaked in salt water. And he kept stacking them until a steady supply of electricity is created. This is called the voltaic pile, and this is the first practical battery that has been made. This finding was so revolutionary that even Napoleon himself paid Volta a visit. Although the battery was revolutionary and was able to provide steady currents of electricity, it was not very practical since it was only able to do that for a maximum of 1 hour, and the electrolytes over time created hydrogen bubbles that would slow the current down over time. To solve the hydrogen problem, a scientist in 1836 by the name of John Frederick Daniell created a new battery called the Daniell cell. In his battery, zinc and copper still acted as the anode and cathode for the battery. However, he he added an additional electrolyte to the battery, so then the second electrolyte would consume the bubbles formed by the first electrolyte. The next breakthrough in battery technology took place in 1888 by a German scientist named Karl Gassner. Up to this point, the electrolyte in batteries are in the form of a liquid, and this caused problems since sometimes the electrolyte solution would often dry out, and because the electrolyte was in form of liquid, this meant that the electrolyte was very prone to spilling. The electrolyte Gassner used was ammonium chloride. However, he added starch to it so then it would become more of a gel instead of liquid. Not only did his battery solve the electrolyte problem, because of its small size, it meant that the battery was more practical and was easier to be mass-produced. The first rechargeable battery was invented by French scientist Gaston Planté in 1859. Planté's battery consists of different cells linked together to create a bigger lead-acid battery. Each cell consists of an anode of lead and a cathode of lead dioxide. A cloth separates the two electrodes, and they're all dipped in sulfuric acid, which acts as the electrolyte. Although this design of battery isn't able to provide currents for a long time since lead dioxide itself doesn't have much active material for a chemical reaction, this battery is still used in situations that require a quick discharge of electricity, like starting a car, or acting as a backup source of power supply for electric companies. Now we're going to look at how batteries work. I'll specifically be talking about how alkaline batteries work, but all batteries will generally work the same way. If we look at the inside of this battery, we can see that we have manganese oxide as our cathode, alkaline as the electrolyte, and zinc powder as the anode. Initially, chemical reactions between the electrolyte and zinc will release electrons that will then stick to the brass pin. However, these electrons want to get to the positive side because, that's where all the party is happening. So to help them, we connect a copper wire connecting the negative to the positive side of the battery. This will help the electrons to move to the positive side. But nothing is free in this world, so we take advantage of these electrons, like how Jeff Bezos take advantage of his workers, and we often connect something in between the path between the negative and positive side. This means that to get to the positive side, these electrons are being forced to do work for us. And when all of our electrons have moved to the positive side, our battery is now officially dead. So, like in all kids' stories, the electrons will live happily ever after in the positive side, right? Wrong! Remember this guy, Gaston Plante, the guy that invented rechargeable batteries? Well, every time when we recharge our batteries, the electricity from the outlet pushes the electron back to the negative side, which puts them into standby to be ready to be abused by us once we need them again. Now I want to talk about the future of battery technologies. The ones specifically I'll be talking about are solid-state batteries. To put into perspective of how good these batteries are, imagine lithium batteries we have in electric cars today as normal Joes like you and me. On the other hand, solid-state batteries are like Olympic athletes that are also using steroids. If we look at lithium batteries, we can see that they have a very bad temper and likes to heat up, catch on fire, and sometimes explode in your face like a Samsung Galaxy S7. In addition to this, they are very lazy and need a recharge very frequently, not characteristics you would want as the battery for your car. On the other hand, solid-state batteries are cool. They charge quicker, they have a lower chance of catching fire, and they're able to work for longer periods of time. Okay, so this is it for my presentation. Hopefully I was being informative and my Microsoft Paint drawings weren't as bad. And thank you all for watching.